All right, so exercise 6 does a better job of approximating what this question will look like on an exam. Again, we have a very short question stem. They've told us a little bit of background information. The drug Lipitor is meant to lower cholesterol levels. And then it says, in a clinical trial of 875 randomly selected patients, so we have our N, who received 12 milligram doses of Lipitor, 53 reported a headache as a side effect. So we have our sample size, and we also have the number of people in that sample who had a certain outcome. So if you want to think about this a little bit, this is our variable is basically headache, yes or no. Right, and then our population are people who are using Lipitor. So I just want to sort of get thinking about this idea that our variable that we're actually going to describe using this distribution is a categorical variable with yes or no. So first thing it asks us to do is verify the requirements for constructing a confidence interval. So we only have one type of confidence interval right now, which is a confidence interval for proportions, and we have an X and an N, which is all about proportions, so we're going to verify those requirements. So again, we'll list them off: SRS, independence, N less than 10% of the population, and our rule of thumb, which is our NP, NQ, greater than or equal to 10. And since we are in a situation where we don't have a P and a Q, we're going to use P hat and Q hat. And so then we go through and check each of those. So simple random sample, yes, we got randomly selected, stated. Independence. Yep, we get that from our SRS. If we are randomly selecting these people, one patient having a headache should not influence the next randomly selected patient having a headache. N is less than 10% of the population, so that's saying that 875 patients is less than 10% of all Lipitor users. This one we don't know, but let's go ahead and assume that this is true, because otherwise we cannot continue. And the last piece is our rule of thumb, the one we didn't have in exercise 5. If we check that out here, 875. Oh, I need a P hat, so let me go calculate that. P hat is equal to X over N. 53 of our 875 had a headache, which is 0.0606. And technically we also need to check NQ hat, but theoretically we can already see that as long as this one is greater than or equal to 10, NQ hat will also be greater than or equal to 10, because 6% of 875 is much larger than 94% of 875. So if we check this out, we get back out our X, because all we're doing is undoing our calculation here. And then this will be the leftover people. Both of those are greater than or equal to 10. So we have everything we need in order to create a confidence interval. So we come to the next step, which says construct a 90% confidence interval for a proportion. So we go to our formula sheet. I'll go ahead and actually do it. We want a confidence interval, we want proportion. There's our formula. Nice and straightforward. It's a nice thing about this particular section. I think it's, easier to figure out what we're doing than it was with the previous. So if you don't have the nice big graphing calculator, even if you do, you may want to write this down just to make sure that even if for some reason the calculations go bananas, you have partial credit. You knew what you were going to do. So you can go ahead and fill this out. P hat was 0.0606. Z star is going to be based on this 90% confidence interval. We'll look that up in that table, or grab it off of our note card, or we have that memorized as 1.645. Then we have our standard error, which is the square root of our P hat times our Q hat, which is just 1 minus that, all over our N of 875. And if you're doing this by hand, calculate your margin of error first, and then add or subtract that. If you have the bigger calculator, this entire thing will be done by doing one prop Z interval. So we're going to go into our calculator. One prop Z interval is in the stats area. And we're not technically doing a test, but all inferential statistics are over here in the test area, with the exception of linear regression. And we're going to go past one prop Z test to all the intervals, and we're dealing with one proportion, and it's a Z interval. So we're going to select that. It asks us what are X, what's our N. Our confidence level it does want to enter as a decimal, so that 90 will be 8.9, and then it will do the math for us. So 0.0473, and our high end 0.0738. I don't know if I wrote that down. Yes, we're good. And it even shows you your P hat and your N. So this is all you need to give. And we're done. And then the interpretation of that interval, that's that sentence from the previous page. We are, or we can be, 90% confident that the, look at your wording from the previous questions, population proportion of laboratory users who report a headache as a side effect. You'd write that again. And then is between 0.0473 and 0.0738. And you do just want to write out exactly as it's stated in the question stem what proportion it is that you're finding. Most of the time, students who try to get too clever with this sometimes end up writing about a proportion that's slightly different than what we actually care about. So just go ahead, recopy down exactly what's there in the question stem.